Today, we will be showing you another tool that is becoming more popular with our project teams, the 3D Virtual Twin. This is a tool that we have implemented on over 10 projects so far and have received great feedback from our project engineering, construction, and pipeline designers. The 3D Virtual Twin utilizes the ArcGIS platform, which allows licensing of the application to flow seamlessly. In this demonstration, we will be reviewing 3 key components of the 3D Virtual Twin tool as they relate to midstream work. The first component that will be demonstrated is the ability to model the Issued for Construction or IFC requirements against real-world obstacles such as existing buried facilities, power line transmission or distribution systems, terrain, and environmental constraints. What you see here is a project that Midwest has taken the engineering alignment sheet requirements, the land crossing requirements, and the company standard requirements, and combined them with our knowledge of typical construction grading requirements for a 48-inch pipeline. By turning on our in-house grading designs and pipeline design information, you get additional visual guides. What you can see as we pan north is the different pipe types shaded by type. Line pipe in green, heavy wall pipe in red, and abrasion-coated pipe in brown. The vertical designs and crossing requirements allow us to determine the depth of the pipeline and the road bore as seen here. Here you have a better view of the lowest pipeline requiring 1.6 meter separation. With straight pipe requirements on either side of the bore, we can see our bell hole will need to be very deep. By using this tool to display this information, we can calculate whether or not there is sufficient temporary workspace prior to the project being issued for bid, or IFB. The heat map shown identifies your depth to the nominal pipe requirements as shown on the IFC alignment sheets. As you can further see, the depth at this bore from the top of the pipe to the graded surface will be approximately 3.9 meters. This should help the pipeline designers and construction management team identify if they have included enough temporary workspace in their regulatory application. As we review the existing facility depth, crossing requirements, and the grading required to complete the construction, we start to see more potential constructability issues. Looking at kilometer post, or KP, 15 plus 100 on this project, we see that when a multitude of constraints are put together, they identify a larger constructability concern that may not normally be identified until the mainline contractor has been mobilized. Moving further south, we come to a large hill, followed by a straight pipe facility crossing, which also has separation requirements. This is then immediately followed by a downhill. Meanwhile, the proposed route is also parallel to 2 hot lines and a side slope. All of these constraints could result in a 15-meter cut. With our IFC and facility model integrations, we are able to detect design issues prior to creating the IFB. What you see at this river crossing is the swamp weights that were on the design alignment sheets. With our 7-meter cutout visualization on, you can see our depths are close to the nominal pipe depth requirements. As we pan north and turn on our 200-meter cutout visualization, you can see the corridor crossing and some of the engineering facility design information. The design proposed by engineering is shown in light teal. As you can see, the current design intersects the existing hotlines. In red, brown, and green, you're able to see our determination for constructability. We have taken into account existing pipeline crossings and the actual crossing agreement requirements from the facility owners. When we take those separation requirements into consideration, as well as the company's internal specifications, we can see that there are some significant changes required as the design did not take the terrain and depth of cover of the existing facilities into consideration. Due to our 3D Virtual Twin tool, our client was able to detect this constraint prior to IFCs being issued. The engineering team then had an opportunity to recreate their designs and make the required changes to the material orders of their design elbows. As the phase of construction progresses, we are able to model the graded right-of-way and then take an analysis on how the pipeline will be constructed. Midwest is able to fly our drones along the route while on site and create models of the grading piles. Here is a graded right-of-way. and we will turn on our interpretation of the main line pipe sections, loose joints, and where the drag sections may be placed. Here you see the loose joints on the side, bent as they would be required to be bent, along with the grading piles. Now turning on our 200-meter cutout visualization, we can get a sense of how the IFC alignment information interacts with the constructability of the pipeline. With the large overbend-sag bend combinations to complete a bore, we know there will be significant room required to the temporary workspace and can ensure that this has been planned for. Here you see a road bore, a pipeline crossing, followed by a power line crossing, and a facility crossover. One thing to note, similar to our 2D application, this map is also interactive and shows the attributes associated with the models being displayed. As you can see, here's the pipe as it would appear in skids next to the open ditch. At KP 35 plus 50, you can see the road bore. As road bores are typically completed prior to stringing, we did not include a loose joint here. However, after the transmission crossing, you can see the requirements for space and piping in order to put the crossing together. Now that you've seen the IFC model come to life and move through the construction phases, one of the final models to be reviewed is the as-built model. Here we have displayed all the pipeline as-built information. You can make queries on the fly for any pipe attributes as well as separation values. We hope you enjoyed our virtual tour of our 3D Virtual Twin tool. For any questions, comments, or concerns, please let us know. Thank you for watching.